today. This is my 14th trip to COMPUTEX over the years. The first time I came here, I talked about motherboards. And I saw the first Pentium motherboards come out. And in the 20-odd years that it has been, I've had the pleasure to do 3 keynotes here. The first time I talked about the future of phones and tablets. And we've seen how Taiwan has really taken advantage of all of that and led the world in some of these new technologies. I then talked about enterprise and how we can see the change of an industry driven by enterprise. But today I wanted to talk about IoT. And it's really intelligent connected devices I wanted to talk about, not phones, not tablets, but that real end node that is the most important bit about gathering data. It's that end node that starts all the process, that little data becomes big data. And I wanted to look at how we could frame the conversation, because I'm an engineer. And engineers like numbers. So I thought, how can I frame this conversation? So laws of big numbers. I like physics. Most engineers are physicists as well. So I wanted to talk about physics a little bit. If you look how many sensors there are on the planet at the moment, there's about 14 billion. That's 14 with a big B. Most of them are in cell phones. There's some in cars. There's some in other devices. But there's about 14 billion. And that's about as long as the universe has been going, 14 billion years. But the opportunity is much bigger than that. And in the next few years, we expect to see somewhere in the 200 to 400 billion sensors on the planet. It's 200 to 400 billion. And when you look at the night sky, that's as many stars as you will see in the universe. They will be connected, these sensors, the same way as the universe is connected. So you'll see gravity connecting them. You'll see them hanging together in a loose configuration. And they will be interacting with each other. So that's how I picture this new world. But I also picture this new world as a huge opportunity as well. Because you'll need low-cost hardware, software, and everything to go drive this. And I think that is a huge opportunity for the next 5 years for this industry to revolutionize. And it is probably the biggest revolution since the PC industry. So how can we go do that? The opportunity ahead of us is to change the world. If you look at that 400 billion sensors, they're going to go into homes and houses, farms and hospitals, cars, medical devices, and everything that you can't imagine at the moment. What will happen is all of those will be connected, and we will have the data we need to change the world. We can monitor and measure almost anything. It's what we do with that that's going to become very powerful. And how we harness that will become even more powerful. We will be able to analyze and get data, but the information we take from that and what we do with it will be the most important bit. And that's where money and businesses will be made. Not just putting the sensors in place, but taking that data and make it into real information. So how do we go do that? I think there is 5 things that you need in a sensor. You need connectivity. Typically wireless, but not always. It needs to be connected in a low-power way to the cloud. The cloud will be as close to the sensor as you can get it, but you will need connectivity to this sensor. Otherwise, the information coming off it won't flow. It needs to be productive, so you'll need to have productivity apps. You need to upload it, change it, make some of the amendments that you need. It needs security. Think of all the data that is coming off these sensors. Your health monitor, your toy that your daughter has, or anything else in between. You want that data to be secure, and you want it to be managed. And most importantly, you want it to be efficient as well. Because guess what? When it's battery connected, you want to make sure that that efficiency lasts for years, not minutes and hours. So let's talk about the first one there. When I first started in the phone industry, they had 3 or 4 inch phones, and they used to last for a few hours. Old men like me remember phones when they used to make phone calls and not just using data. That's why they call them phones, by the way. Look at phones now. You have batteries in there that are 300 milliamp hours, 3,000 milliamp hours. You look at watches with screens have 300 milliamp hours. You go down the scale, and on the left-hand side, you will see some embedded devices with a 130 milliamp hour battery. As you can see, the battery now is actually larger than the device. How do you shrink that battery? You make the device more and more efficient. Battery technology will not scale with Moore's law. We have known that over the last 20 years, and it won't change in the next 20 years. So the only way to be productive is to make that SoC, that board, as effective and efficient as possible. Otherwise, we have to power them up, and we won't use them. So firstly, efficiency is important. Let me talk about radios. Radios are very power hungry. Why? Because they're always on. If you think about what a radio is, it's waiting to wake up the rest of the system. One of the ways to make systems more efficient is to reduce the power in the radio. So we've been working closely with a number of companies, including TSMC, on 55 nanometer technology. And what we're able to do now is make radios much more efficient. So we've launched a product called Cordio, which is Bluetooth low power. But what it does is it reduces the voltage in the radio below 1 volt. That gives you 60% more battery life. Let me repeat that, 60% more battery life. It's a huge saving on these very small leaf nodes. And you look at the size of the battery that I showed you before. To compensate for that, you will need a 60% bigger battery. That is going to kill some of these devices. So efficiency in a radio is really important. Efficiency in software is also important. I think there's a huge opportunity here in Taiwan to drive some of these software initiatives. Because when you have sensors, they need to run small operating systems with applications feeding into the back-end cloud. So revolution going to happen in some of these software industries, and we think that there is an opportunity in Taiwan to really go drive this. So not just the hardware, but the software is going to change, and it needs to become small, compact, and efficient. We think that can happen here. But then you have to put it all together. And some of the best SoC companies in the world are based in Taiwan. So we put together some of the building blocks to go do that, to make it much more efficient to drive low-power, low-cost SoCs. But as Johan said, and as Stan said, it's really about the development environment. and you look at all the companies that are going to be formed. And we reckon in the next 5 years, 50% of all the IoT companies will be 3 years old or less. 3 years old or less. If you want to go and change an industry, as the PC industry changed, now is the time to drive that industry, drive those new thoughts into new companies. We think there's a huge opportunity, and as an industry, we need to put those building blocks together. So we think there's a lot of these motherboards that are coming out now, which are low cost, good design environments that will drive IoT development on the software. We think you can get it from more than one place. In fact, as an industry, we've got tens, if not thousands, of these coming out, from the very small to the very famous, from the Raspberry Pi all the way through to things that are as small as 1 cent. You can now take a development board, put your software on it, and take it into production very, very quickly, driven by low-cost manufacturing and design, which happens here. But we didn't want to stop there. So we're working with UNICEF to set targets for their lab, which enables the developing world to get access to this technology, which allows new thoughts and new ideas from around the world. So if you have an idea of what an IoT sensor can do, you get access to boards, technology, and software through UNICEF as well. We think this is a big opportunity for everybody to participate, not just Western Europe and North America. This technology and ideas know no boundaries. For an industry, we need to make sure that all business people get access to this. But, and there is a huge but, you're now going to get 100x, 1,000x, 10,000x more data going across the network. If I'm going to put a sensor in every light bulb, if I'm going to put a sensor in every air conditioning unit, in every thermostat, in every child's toy, you're going to get significantly more data going across a network. And how are we going to handle that? As an industry, we need to look at ourselves and go, you can't just keep on building bigger and bigger data centers. That doesn't scale either. We'll be building a lot more power stations to put these sensors in if we keep doing that. So you look at 5G, you look at where that's going, and you go, can that help us? And the way that 5G has been designed can really help IoT in the backhaul. You look at the way it's gone millisecond latency. It's designed for an M2M world. But the other thing it says, you have fixed power and space requirements. You have to do more with less. You have to do more processing with the same amount of power that you've got now, or less power. And with data coming off 4 billion streetlights in the world, because when we put sensors on every streetlight, that's 4 billion, you're going to have to put data centers in new locations. And it may not have power and it may not have cooling. How do we go handle that? And as an industry, we've started to think about that as well. So we've called it the intelligent, flexible cloud. What this really is putting processing into the cloud and into the network where it's optimally efficient and the right place to do the processing. At the moment, you grab data off a sensor, send it all the way back to a data center, and send it all the way back again. If you get 1,000x the data coming through the network, you will overload the data. We reckon that 50% of the current networks will fail at some stage going forward if IoT expands the way it's forecasted to be. So we look at this and we go, how do you get data processed at the right space? We think there is an opportunity to do about 40% of the processing actually in the node. And then at each stage along the path, you add more and more processing, more and more storage, so you reduce the bandwidth going through the network, and you do the processing at the right time. But that only happens if you put intelligence in the network and you write the software to go do that as well. And as that revolution happens, there is opportunities to do hardware and software in a new location, driven out of a need and a desire for change. And we think there's opportunity there as well. In the enterprise space, huge change will happen around compute, storage, and acceleration in the cloud as the cloud changes from a client-server relationship to one which is sensor into the cloud. If we do that, we can actually deploy 200 to 400 billion sensors. If we don't, the power requirements of the network will overload the sensors and we won't be able to deploy anymore without building significantly more power stations, which nobody really wants to go do. So, we looked at this and we put it into practice, and we put some servers into practice. And people say to us, well, ARM-based servers are not really good for anything. So we went and checked it out with a few people. So Hewlett-Packard and us, Linux company, got together with PayPal. And PayPal said, come and put an ARM-based server in our data center and run applications, because they believe in this flexible cloud. They believe in payments are going to triple, quadruple, and they need much more efficiency. So we put real servers from HP based on ARM in PayPal's environment. And here's the results. Acquisition cost, 9x down. Power consumption per year, half the current power environment. More staggering, no density per rack, 7x. Now, if you're in the middle of Taipei and you're trying to double and triple your data center, that's going to cost you a lot of money. I looked at buying apartments here, really expensive by square meter. The way you go and increase the data center size in Taipei is not by adding more racks, but by making the square meter that you've got currently in use much more efficient. Driving the wattage per square meter of a data center only happens if you have efficient processing, and we think that the ARM-based processing can get you there. To do that, we need to change an industry again. And we think there's opportunity there, especially in Taiwan, to drive new server designs. So this week, companies like Advantech and Gigabyte have announced ARM-based servers and working with us in this new IoT world. Huge opportunities here to revolutionize an industry based here, but revolutionize the world, because we think there is opportunities there as well. And I come back to space. I love stimulating new ideas. I love stimulating children. I love stimulating entrepreneurs. But this one blew me away. Competition running on a Raspberry Pi. NASA will take a Raspberry Pi into space. It's called an AstroPi project. And children are having a competition at the moment to program it to do things in space. I'd never have thought how to go do this, but having ARM-based chips in space being programmed makes me so proud that this can go on and we can change an industry and stimulate the children and stimulate the entrepreneurs to go do this. But, and I come back to the but, my talk was all about sensors to servers. I think there's 200 to 400 billion sensor opportunity out there. That's hardware and software. That's driven by silicon, driven by embedded software. But there's opportunities in security because we want to have that data secure so the consumer can control who sees it. I may not want my heart rate monitor feeding directly into my insurance company. I may not want my daughter's doll with its IoT microphone in there going back and listening to all of my conversations or all of my daughter's conversations. Security is going to be important. Low power is going to be important. And low power comes from efficient processing and efficient radios. We need to have both. We need to have productivity apps. We need to be much more efficient about how we design the hardware and how we design the processor. And we have an opportunity to stimulate new people to go do that with development boards, with software and tools that make it easy for them to go and design these new things. Make it easy for people who are not computer literate to design products, because that's what we should be doing. And if we get those 200 billion, there's an opportunity then to change the way the cloud works, to move it as close to that sensor as possible, and to have processing all the way through. Because if we don't, we end up building new power stations to run the data centers. So people go, sensors to servers, why do you talk about that? And my answer is, because they're so interconnected. If you do one and not the other, they'll both fail. You need to change the way the cloud works, and you need to change the way the sensors works, and you need to change the software environment. And so I go back and I go, this is the biggest revolution in this industry since the PCs were invented. And it is the biggest opportunity to go and start new businesses, because 50% of all the businesses that are going to come into IoT in the next 5 years will be less than 3 years old. So if you want to start now. If we do that, we create an opportunity, not just here, but around the world, to stimulate these new talent. And if you do that, you may just change the way in which those sensors monitor things that are going on. And we may be able to understand really how to go control everything on a global scale. From healthcare to education to home to automotive. All of those sensors are connected. All the billions of stars are connected. Everything is connected. And if you change one little thing, it'll affect everything. We need to think of that globally and across the universe, because that is the opportunity going forward. Now is the time to do that. If you want to do it now. Because in 5 years' time, somebody will have cracked it, and we'll be looking at something else. Revolutions happen at certain stages in an industry. Now is the time for the IoT revolution. Thank you very much indeed.
Thank you once again, Mr. Drew, for his professional ideas about scalability and efficiency for this connected world.